Hello, friends. Welcome to Hydraulics and Hydraulic Machines class. In today's class, we discuss on discharge, work done, and power required to drive a reciprocating. Let us take two problems in the portion which we have completed. If we are doing any problem in this, the topics which we have covered, number one, what we mentioned is, for example, discharge. This is one equation which you should know. The discharge is Q is equal to, it is ALN by 60. This is in case of single acting reciprocating pump. In the case of double acting the reciprocating pump, it is equal to 2ALN by 60. It is double acting. Suppose, for example, some problem comes on double acting, giving the piston rod diameter also, then also there is nothing to worry. It is basically Ln by 60 into this areas only. It will change pi by 4 into d square plus pi by 4 into d square minus d square, where small d is the diameter of the piston. So area of the cylinder, length of the cylinder, or N is the speed of the crank, right, in RPM. And then here capital D is the diameter of the cylinder, small d is the diameter of the piston rod. So this is one equation. The second equation for us is where after discharge, then actually the weight of liquid delivered per second. It is nothing but actually gamma specific weight into Q, that is second. And third is work done per second. The work done per second is nothing but gamma Q into the total height, HS plus HD, where HS is the suction height and delivery height. And here, if you want to write the equation, gamma into ALN by 60 into HS plus HD. It is in the case of single acting reciprocating pump. It is single acting reciprocating pump. And you want in the double acting reciprocating pump, gamma into 2ALN by 60 into HS plus HD. This is double acting reciprocating pump. Then power is equal to the last one. Power is equal to, you determine basically the work done per second and express it in terms of kilowatts. So this is in terms of kilowatts. So this is over. Then next one is, what is coefficient of discharge? Coefficient of discharge, CD is equal to actual discharge divided by theoretical discharge. Then what is slip is equal to? Slip is equal to theoretical discharge minus actual discharge. What is percentage of slip? Is equal to QTH minus Q actual by QTH into 100. This is nothing but actually 1 minus Q actual by Q theoretical into 100. It is equal to 1 minus CD into 100. Then last, actually negative slip when occurs, yeah, already points I mentioned. So these are the equations. You should actually have an idea before taking up any problem. Let us straight away let me take a problem. Any number of problems, principle is same. So that's why I take a problem. Let us take it. A single acting reciprocating pump running at 50 rpm. Okay, delivers 0.00736 meter cube per second of water. The of piston diameter of piston is nothing but actually the diameter of a cylinder. The diameter of piston, not piston rod, piston is 200 mm, and stroke length is nothing but the length of the cylinder. Stroke length is 300 mm. The suction and the delivery heads are 3.5 meters and 11.5 meters respectively. Determine theoretical discharge, coefficient of discharge, percentage of slip, power required to drive the pump. Coming to the point directly to the solution, what he has given is n is equal to 50 rpm. This is first thing. Q is equal to 0.00736 meter cube per second. Then naturally the next question is which Q it is. Theoretical discharge is from the formula. So this is the actual discharge. So that is over basically. Then what more he has given actually diameter of the piston, that is diameter of the cylinder is 200 mm. Then what more he has given? HS is equal to 3.5 meters. HD is equal to 11.5 meters. So any other things? Stroke length L is equal to, it is 300 mm. 0.3 meters. Kindly remember that this stroke length is equal to twice the radius of the crank. So now let me go into straight the point actually. So first question is coefficient of discharge. CD is equal to actual discharge by theoretical discharge. Theoretical discharge, it is a single acting reciprocating pump. It is 2 in, sorry, it is ALN by 60 straight. What is A is equal to pi by 4 into D square. That L is given, N is given. So now substitute it actually pi by 4 into diameter is 0.2 whole square into length is 0.3 into RPM is 50 RPM divided by 60. So if you calculate this actually into, see, this is a theoretical discharge in ALN by 60, right, over. So if you calculate this, how much you are going to get the discharge actually, if you do it, it is nothing but actually 0.00785 meter cube per second. Once this is over, discharge is over, then actually coefficient of discharge CD is equal to what they have given actually actual discharge by theoretical discharge. Actual discharge is 0.00736 divided by 0.00785. So it is equal to 0.937. This is the first answer. Over. Then second answer, let us go into the second answer. What is the second thing they have given actually? Percentage of slip. Percentage of slip is nothing but QTH minus Q actual divided by Q theoretical into 100. So now you write it. What is Q theoretical? You got 0.00785 minus 0.00736 divided by 0.00785 into 100. If you calculate this, how much you are getting? Basically around 6.24%. This is the percentage of slip. Then actually what is the third question he has asked? Basically theoretical discharge is over, percentage of slip is over, then power required to drive the pump. Power required to drive the pump, already I mentioned, gamma into Q, this is first thing, into HS plus HD. If you put it this, you will get work done divided by 1000. So gamma is equal to 9810 into Q is already you got 0.00785 actually, previously you got it, into basically this is HS is 3.5 plus 11.5 by 1000. You get actually 1.155 kilowatts. This is the first question. All I have done in one problem itself. Very simple actually. There's nothing much difficult in any of the problems in this particular reciprocating pumps. The second problem, just for your sake, I will do a double acting reciprocating pump. Having piston area 0.1 meter square, has a stroke 0.30 meters long. Full stop. The pump is discharging 2.4 meter cube per second of water. 1 second. 2.4 meter cube of water per minute, not per second. They have given this in minute. Yet 45 RPM through a height of 10 meters. That means total height he has given HS plus HD. Then find what the thing slip of the pump. power required to drive the pump. So let us see what he has piston area. So that means area is equal to zero point 0.1 meter square. Then what is given? L is equal to zero point 0.3 meters. And discharging means this is now whatever he has given, Q is equal to 2.4 meter cube per minute. But discharge cannot be in minute. So 2.4 meter cube by 60. So this is per second, right? Then what more he has given? N is equal to 45 RPM. Then he has given HS plus HD both together 10 meters. So this is the thing. I want slip. If whatever I want, first thing I need to find out theoretical discharge. Theoretical discharge is equal to double acting reciprocating pump. So 2ALN by 60. Otherwise, single acting is ALN by 60. For double acting, it is 2ALN by 60. So 2 into A is 0.1 and L is 0.3 into 45 divided by 60. So if I calculate it, I got 0.045 meter cube per second. Then already Q actual is equal to 2.4 by 60. I'm getting 0.040 meter cube per second. Therefore, basically, slip is equal to theoretical discharge minus actual discharge. So it is 0.045 minus 0.04. So this is the slip actually, which is equal to 0.005 meter cube per second over. Then what is the power? Power required to drive the pump is equal to, actually it is uh, um, gamma 2ALN by 60, which is nothing but the discharge into the total height. Total height is HS plus HD by 1000. If you put in kilowatts, you will get the power. So now let us take it. This is nothing but actually the discharge. So gamma is 9810 into Q is equal to 0.045 basically. So right, this is theoretical discharge into head is 10 meters, that is given, divided by 1000. So if I do this around, I am getting 4.415 kilowatts. This completes to me the second problem. So with this, I have done both the single acting and double acting reciprocating pump for your reference. So now the first part, if I take it, this part is closed. So kindly prepare up to this thoroughly, right? Starting from, right, what is a reciprocating pump? Number one, what is the principle of reciprocating pump? Number two, their components of reciprocating pump. Number four, basically the working of reciprocating pump. Then number five is how to derive the equation for discharge. right? Once discharge is over, work done is over, then power in the case of single acting reciprocating pump, double acting reciprocating pump. So these are the important things. And now I conclude this part actually by saying when we will use reciprocating pump. Reciprocating pump, we will use it when the head is very high and discharge is small, then definitely we will go for reciprocating pump. With this, the first part we complete with the two lectures with problems. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.